Hello, this section is entitled Deploying a Google Kubernetes Engine Cluster. So first, a couple bit of terminology. First, containers. Essentially, a container is a packaged up piece of software that includes both the application itself, all its files, and then along with all its dependencies, and an OS kind of all bundled together into a single, essentially a container image file, which then you can execute. Now, you can read about this on your own more, but in general, we can compare this against what we did previously when we ran a GCE instance, right? In that case, we picked an operating system. It got installed from an image. Then we went in and we installed Apache. That's like a dependency, right? Manually using like apt commands. And then we had to install our code. In this case, it may be the HTML file itself, right? So those operations were all separate. They weren't all packaged together in one thing. In this case, the container could actually have the operating system, all the software you needed, and all your code all put together in one thing, and you can deploy that. So it becomes a very predictable kind of development process when you know exactly what operating system, exactly what dependencies you have, and your code all at once. So it's pretty much the de facto standard for modern development. So you may already know it. Okay, so one thing you may not realize, which I did not realize, when we were in GCE and we were creating instances, there was actually an option, and maybe I'll just talk about it as I go to it. If I create an instance here, we're not going to create it. I was going to show you up to the point where we create it. So when we were creating instances previously, we did not check this little box right here. And in which case we picked the boot disk, right? And which is basically the operating system. And then we went down before, if you recall, we used the startup scripts down here to install dependencies and then ultimately install our code, which is the HTML, right? But instead, one option you have here on GCE is to check this little box, as container. Here, what they're going to do is they're going to pick the operating system for you, which is this container optimized operating system that Google provides, which basically has your container engine, operating system and your container engine, say Docker, all together, right? And then your deployment really amounts to providing a container image, which is a bundled operating system dependencies in your code. So you can actually do this on GCE sort of natively, and then what you can do then is, of course, you can take advantage of all the scaling and health checks and stuff like that that GCE offers, and treat this as your container management system. Now, the problem with this is that it's very specific. It's one, it doesn't have a whole bunch of features, and two, it's not really open source in the sense that it doesn't build upon a long history of open source. So, means that it's not going to be portable if you try to use the same technique at Amazon or Azure, right? It's very specific to Google. So, a more popular choice today is use an open source solution, right? And in this case, Kubernetes is probably king in this space for running containerized applications. And basically it automates a lot of the same things we saw with our like auto scaling management groups and stuff like that, but it does it in more of a standard open source way, right? So Kubernetes is basically an open source system for automating, deploying, and scaling and management of containerized applications. So in this case, we're not going to run a GCE instance directly and then run one container on it like what I just showed you with GCE. We're going to do something different. Now, I think one thing that's super helpful here is a diagram, which I will open up a new window. See if you can find it. So just so you know, Kubernetes has a ton of documentation, and I've actually created a whole video series on it. So we're just going to really touch upon the main concepts here and then move on. But so one thing to get in your head about is what is Kubernetes, right? You still have instances. You have computers running, right? And then there's, just like we just showed you in the example ago, just like GCE, we ran a container on top of an existing operating system. We essentially do the same thing on these things called nodes. So a cluster is sort of the high-level object, which is a group of nodes that run containerized applications. Now, there are a special set of containers essentially running on one of your nodes. It's called the control plane, which basically does a lot of the deployments, scheduling, kind of the guts of the logic of how these containers get run and how they scale up and stuff like that, right? So what you should be thinking of is you have a bunch of, imagine you have a bunch of GCE instances, right? And they're running as nodes, and those can run containers, and some of the containers there are the control plane, and some are your personal workloads, right? So that's what, at the highest level, what a cluster is. It's basically a bunch of nodes that run containerized applications. So again, you could read this on your own. I'm sure I'm not getting it fully right. So now you know conceptually what a Kubernetes cluster is and what their nodes are. You can go to Google and you can run this different ways. So one is, even before you do the Google way, literally you can do is you can start off from their documentation, the Kubernetes documentation that is, and you spin up some GCE instances. You say you put Ubuntu on them, right? And then they have nothing else on it initially. Then you can install onto those. You can install your container engine. So maybe it's Docker, right? So that allows you to run containers on those nodes or those instances. And then there's one last step where you kind of bootstrap them as a node, and you group them all together, and you call that your cluster. So in this case, you're self-managing your Kubernetes on top of GCE. Google had no hand in doing anything other than delivering you just raw GCE instances. So that's one solution. The problem is, it takes a bit of work to set up Kubernetes, and you might want redundant control planes, like you want more than one copy of those things that are doing your scheduling or your managing your deployments. So it's takes a fair amount of effort to set up a fully self-managed, redundant Kubernetes cluster. So Google's got a thing where they call it GKE, right? And they basically manage the control plane completely for you, and even set up the nodes. And you pay for the nodes, but they're just GCE instances in your project, right? That you can see and you can actually log into if you've wanted to. But Google basically manages the nodes, like the upgrades of them and whatnot. That's called GKE. So that's one. And then the nice thing about it is it's not much more expensive than if you were to run your own redundant control plane and then your own nodes. So that's a nice way of doing it. Now, Google's got another recently released feature. They have a kind of a nodeless experience. It's called autopilot. So in this case, you don't even see the nodes. When you turn this thing on, you get a control plane, you get nodes, but the nodes are kind of hidden from you. You don't even see them in your project, and you don't even pay for them. You only pay for your running, kind of your containers themselves that are running. So it gives you a lot less control, but it's cheaper and less work. So that's called autopilot. So you have your regular just so far you can run your own self-managed Kubernetes on GCE. That's sort of a baseline. You can move up to, which a lot of people do, is move up to GKE, where you still have the nodes in your project and you can troubleshoot them directly, but they're managed along with the control plane by Google. Control plane you can't see at all. The next level is this new autopilot mode, where now both the control plane and all the nodes are essentially invisible to you, and you just run your own workloads, and you're only paying for the pods, right? And then there's kind of a, it's not an evolution, it's kind of an older product called Anthos. It's more like GKE, but in this case, Google takes over more control over the Kubernetes cluster and adds kind of commonly used add-ons to kind of bundle into this more complete solution called, and then it has integration. You can do things like you can run clusters in the cloud as well as on your premise, right? So it's a much more expensive kind of corporate product. But it basically, the way you should be thinking of it is, it's basically GKE with a bunch of add-ons added that Google manages instead of you having to manage those add-ons. Okay. So, and then this is an evolving set of options. So, like that, this autopilot's really new within the last couple of months. So it's even new to me. Okay. Now let's go back to this. We're going to create a cluster. That's the whole point of this section, right? And there are really two choices when you create a traditional GKE cluster. This is what I mean is not the autopilot one. This is where you run the nodes in your project, right? There's two options. One is called a zonal, and one is called a regional. A zonal one essentially gives you a single control plane, so it's not redundant, right? So so this lives in a zone, the zonal. So if that zone goes down for whatever reason, then you lose the control plane because the zone's down, and of course then you lose your cluster. A more reliable solution is called, and it's more expensive obviously, but they basically now run multiple control planes, copies of it, in different zones in a region. So you define a region and then it picks the zones to run in, and that way if one zone was to go down, you can also spread your workload nodes across different zones and have redundancy. You can do redundancy in your own code, and then the control plane is redundant. So you can actually survive a zonal failure because you have both the control plane and your workloads are in multiple zones. So that's what's called a regional cluster. Now, I think what we're going to do is we're going to create a zonal one because it's less expensive. And so one way of doing this is from the command line, which I'm not going to do because it's hard to visualize. So I'm going to use the console here. So the first thing you go to is, I'm going to pin it. So you put a pin in Kubernetes engine, and then I go to clusters. And I can't remember if I've activated this yet. I have not. So I'm going to enable this and then pause the video until this is enabled. So push the button, pause the video. Okay, we're back. So now that the API is activated, now I can actually create. And I'm going to use, so again, here's your two choices. You have standard or autopilot. This is, again, new. I'm going to use the standard one. Whatever this is, it must have changed their UI, of course. So just kind of walk you through kind of the basics of it. First of all, remember we talked about you name a cluster, you give it a zone. So I'm going to type zonal or regional, and then you pick the zone, right, in a zonal case. So I'll just leave everything alone, right? The control plane here, one of the things you can do is you can have Google manage the version of the control plane for you, or you can then pick a particular version, right? I'm going to probably just use, I'll just use what their default, which is they have a regular channel, which is they upgraded on some kind of a safer path than they have their rapid, which is like their bleeding edge, and stable means they kind of lag a little bit. So I'm going to leave it with a regular channel with their current version, which is 118 something. That's basically it for the basics. Now there are other things you can configure, but we're not going to go through all of this. There's a lot of details. right? Some added, basically what this is doing, it lets you indicate how your cluster scales, maybe if it needs to grow, the cluster itself. You can get into things like security. There's lots of stuff. So that's outside the scope of this whole course, right? So I'm going to leave that alone. So I think I'm just going to create this and then pause the video. Basically just shows all the defaults. So I'm going to pause the video for the moment because it's going to take a few minutes. Let me clean up all this pop-ups. Okay, I'm back. Took about 5 minutes. Actually, I had to eventually just refresh the screen and then it was done. So it probably took less than 5 minutes. But so here we see sort of a summary. We have a cluster called, name is cluster 1. It's in US Central 1C. And the number of nodes it has is 3. So it's basically, you know, we're not running any of our code in it, but we have now something we could run our code on. Now, just one thing under the hood to remind you, if I go to Compute Engine, you should see 3 instances here running our nodes. So there's 1, 2, 3. Google is managing these for us. We're paying for them, and we can still log into them and troubleshoot them, but Google's responsible for at least, you know, upgrading them, basically keeping them up and running at some level. Now, one other thing here is remind myself too is that these are called worker nodes. So while there are some containers running on here that are part of the management system, the bulk of the cluster's management is in the control plane, which is running essentially on nodes that I don't see. And in this case, I did a zonal one, so there's only one of them running in the same zone, US Central 1, but on one of Google's projects, essentially. So I can't log into it, I can't see what's running on it, but it is there. And these 3 worker nodes do talk back and forth with it. Okay, a couple commands we can mess around with. I think the first one I'm going to do is, if I can get this right. Actually, it's in the notes here. Let me make sure I go to my notes. Right. So one thing, you know, we've been looking at from the perspective of the Cloud Console, there is a whole bunch of commands one can run. Gcon, containers, container, clusters, and then list. Now, if I do this, it's not going to work because it doesn't know what zone to look for. So I'm going to do zone equals US Central 1C. I think this should work. Right. So here it is again, essentially the same data that you were looking at in the Cloud Console. You can see the cluster here, what zone it's in, its version, basically this number of nodes, for example, right? There is an IP address for the control plane, and that's basically so that when we run our commands, which we'll run in a minute, that's the IP address we end up talking to. So the next thing we're going to probably need to do is, right, so the next concept and tool we'll need is called kube control or kubectl. I'm not sure how people pronounce it, but I think I use control, but I think I've heard cutl too. This is basically a command line tool that allows you to, you know, interact with the cluster directly. This is how you can deploy your workloads, you can inspect your workloads, you can do all sorts of stuff, right? And there's a couple ways you can install kubectl. I'll say kubectl, so that sounds better. You can install it directly, so you can go to just look up installing kubectl from, and then depending on your operating system, Mac, Windows, or this, you can install it that way, and that's fine. Because it's an integral part of Google's offering, they actually offer a way of installing it through gCloud, and that's how we'll do it. There's one trick here, though. You got to be careful, and I don't think Google fully manages this for you. Kubectl has to be, the version of kubectl has to be within one minor version of basically your cluster's control plane. So we're running this right here. That's the control planes version. 118. So I can use 117 or 119 kubectl with this, but I can't use 116, right? So it's one of the things to be concerned about. So if for some reason you're running a different version than what this gcloud will install, what you'll do is you'll uninstall it from gcloud and then you'll install it manually. You can install the right version. So in this case, I'm going to install it this way since I know it will work because I checked it earlier. But I'm going to run kubectl. Now I've already installed it this way, so mine just says all components are up to date. And then if I run kube control version, you can see that the client version is 117, right? And 117 is within one minor of 118, so this combination should work fine. So that's the next step. Okay. Okay, so the next thing we need to do is when I run kubectl, it doesn't, well, you can see it already kind of had a hint here when I ran the version. It didn't know what a cluster to talk to because I never configured it to configure it to a cluster. So it assumed it was localhost, and of course it failed, right? So what we need to do is we need to configure kubectl to know about our cluster 1. Now Google has it, and basically authenticate ourselves to be able to interact with it. So the way you can do this is, in fact, I think I got this, except for I got this the wrong zone. Let me copy and paste this and we'll talk about it. So in this case, there's a gcloud command, gcloud command, right? Container clusters, but this get credentials. You give a cluster name, and then you have to tell what zone it's in, and this is our zone. And what this will do is it will basically now go out and get its IP address, 1, so it knows what IP address to talk to, and then it also will get credentials, so then I can run commands against the cluster. In fact, I can just run kube control version again, and right, it should now tell me my version of the client, 17. Actually, interesting. I have to figure that out. See, now it says it's 118. I think the other one said 117 plus, so probably was really 118 running. That's a little confusing because I didn't change my kubectl, but now it says it's 118, and the cluster itself is 118. So that is interesting. I'll have to look at this later because I swore we had 117 just a minute ago. So maybe kubectl can adapt itself a little bit, which is a little confusing to be honest. Okay, that's kind of threw me off there. Okay, so the only thing we're going to do is we're going to actually use kubectl to do something. And really the only thing we've talked about are nodes. So I'm going to do kubectl get nodes. So that goes to the control plane and asks what are the nodes. And you can see that we've got 3 nodes. It's the same 3 instances that we saw in GCE. And then just so you know, the nodes themselves have their own version. Now usually you try to keep these versions the same as your control plane, but they can drift. During an upgrade, you typically upgrade the control plane first, and then you upgrade the node second. So the nodes are separately versioned. Okay, that's it for this video. The next video we'll start getting into actually using it to run our workloads at some basic level.